Hello and welcome to my channel MathyThinkers. In this video, we are going to look at surface area of solid shapes or 3D shapes. First, let's look at a cube. So this is how a cube looks like, and this is how its drawing looks like. So suppose we have a cube whose all sides are 5 centimeters in length. So all of its faces are squares, and there are 6 such faces. So we have to do 6 times the area of one face. 6 times the area of one square. So that will be 6 times 5 square, which will be 150 square centimeter in this case. Square centimeter. Now let's look at this cuboid here. So this is how a cuboid looks like, and this is how its drawing looks like. Suppose we have a cuboid whose height is 2 centimeters, width is 5 centimeters, and length is 10 centimeters. So what we are going to do is, we are going to find out the area of each of these surface and add them up all together. So if we look at this surface here, so there are 2 of those. Similarly, there are 2 of this, and there are 2 of that, the top and the floor, right? So we are going to find out the area of each of these and add them up. So we are going to do 2 times 5 plus 5 times 10 plus 2 times 10, and we are going to multiply all of that by 2 because there are 2 of each of these rectangles. So that will give us 2 times 10 plus 50 plus 20, which is 2 times 80, which is 160 square centimeter square. Now let's look at a cylinder. So this is how a cylinder looks like, and this is how its drawing looks like. Suppose we have a cylinder whose radius is 5 centimeters and length is 10 centimeters. So if we draw the net of the cylinder, it looks like that. So it has 3 surfaces there, 2 circles and 1 rectangle. So the curved surface is actually a rectangle. Now for this rectangle, the length, this total length of the rectangle is actually the circumference of this circle. So that is 2 pi r. We know that the circumference of a circle is 2 pi r, right? So this length of this rectangle is 2 pi r. And the width of this rectangle is that, which is 10. So if we have to find out the total surface area of this cylinder, we are going to add up this surface plus that surface plus that surface, right? So we are going to do 2 times the area of the circles, which is pi r square. R is 5 here, 5 times 5 square. Along with that, we are going to add up the area of the curved surface, which is 2 pi r times 10. So that is 2 times pi times 5 times 10. So if we calculate that, we are going to get 25 times 2, which is 50 pi. And from here, we will get 2 times 5 times 10. So that's 100. So that's 100 pi. So in total, we have 150 pi. If we use the calculator, we'll get a value of 471.24. rounded to 2 decimal places. So that is the total surface area of this cylinder. Remember to write this rounded to 2 decimal places once you use any rounding in your answers. Now let's look at a triangular prism. So this is how it looks like, and this is how its drawing looks like. So we have two triangles, let's call them the triangular bases, and three rectangles which together make up the lateral surface. In order to find out the total surface area of this prism, we have to add the surface area of these two triangles with the lateral surface area of the prism. So let's do that. So first, let's find out the area of the triangles. So if the height is given as 5 and the base is 10, so half times base times height, which is half times 5 times 10 in this case, will give us the area of one triangular face. So that is 25 square centimeter. That's one triangular face only. So 2 times area of triangular base is 2 times 25 in this case. 2 times 25, which is 50 centimeters square. So now we have to find out the area of the lateral surface, which consists of 3 rectangles there, right? So the first rectangle I'll show you with a different color. So the first rectangle is 6 times 20. So that's 6 times 20. Along with that, we are going to add the next rectangle, which is 7 times 20, right? So 7 times 20. And the last one is the one at the floor, which is 20 times 10 plus 20 times 10. 20 times 10. So if we add all of that up, we are going to get, if we add all of this and that, we are going to get 510 as the total surface area of the triangular prism. Now let's look at a right circular cone. This is how it looks like, and this is how its drawing looks like. It is called a right circular cone because its apex is directly above the center of the circular base. In other cases, there can be oblique circular cones where the apex is not directly above the center of the circular base. For our example here, let's take that the slant height S, this slant height is 10 centimeters, and the radius of the circular base is 5 centimeters. In that case, let's calculate the surface area of the circular cone. So the total surface area will be area of the circular base plus area of the curved surface. So this is the curved surface. So for the circular base, we know that the area of a circle is pi r square. So that is pi times 5 square in this case. And if we add the area of the curved surface, that will be pi times s times r, which is pi times r times s, that is 10. Pi times 5 times 10, pi r s. So if we calculate that, we are going to get 25 pi plus 50 pi. So that is 75 pi. If we use our calculator, we'll get 235.62 square centimeters rounded to 2 decimal places. Okay. Let's look at another scenario here where we have been given the standing height and the radius. In this case, we have to calculate the slant height using Pythagoras theorem. So if we look at this triangle here, that is a right angle triangle. So we'll apply Pythagoras theorem here to find out the length of the hypotenuse, which is the slant height in this case. So S square is actually equal to 3 square plus 4 square. So that is 25. And if we square root 25, we'll get the value of S, which is 5 centimeters. Now we will apply it in our formula. We'll use it in our formula to find out the total surface area of the cone. So we will do pi times radius square, which is pi 4 square, and pi rs. So pi times 4 times 5. So that comes out to be 36 pi. If we use our calculator, we'll get a value of 113.10 centimeters square, rounded to 2 decimal places, rounded to 2 dp. Now let's look at a sphere. So this is how it looks like, and this is how its drawing looks like. So if we take the cross section of the sphere at the center, that is just a circle. Suppose its radius is 5 centimeters in this case. So the surface area of the sphere will be 4 times pi r square, which is 5 square in this case. As simple as that. So that is 4 pi 5 square. If we calculate that, we'll get 100 pi. And then if we use our calculator, we'll have 314.16 square centimeters, rounded to 2 decimal places, 2 dp. Next, we will look at a hemisphere, which is half a sphere. So a hemisphere will actually have 2 surfaces. The first one is the circular surface there at the base. That's the circular base. And the other one is the curved surface on the top. So the curved surface on the top is just half of the surface area of the sphere. So if the surface area of a sphere is 4 pi r square, half of that is 2 pi r square. So area of this surface on the top is just 2 pi r square. And the area of this circular base is just a pi r square. That's just an area of a circle. So if we now use the formula, we'll have 2 pi r square plus pi r square, which is 3 pi r square. So in this case, it will be 3 times pi times 5 square. That will be 235.62 centimeter square, rounded to 2 decimal places. Finally, let's look at an example. The question says, find the surface area of the following right pyramid. We have been given the diagram of the right pyramid here. We can see it has a rectangular base, and there are 4 triangular faces standing on the rectangle. So we have been given the standing height of the pyramid, which is 40 centimeters, and the length and the width of the rectangular base. So let's quickly find out the area of the rectangular base. So that's 30 times 20, length times width, which is 600 centimeters square. centimeter square. Next step will be to find out the area of these two triangular faces, this one and that one. Let me highlight that. So this triangular face and that triangular face. Let's find it out. In order to find out the area of a triangle, we will need its height. So let's that be the height of this triangular face. Let's name that as S1. So let's name that as S1. So if you look at this triangle now, this is a right angle triangle where we know that the height is 40 and the base is 15, because that is just half of this side. So this is half of 30, so that is 15. So S1 will be square root of 40 square plus 15 square. So if we use our calculator, we'll get a value of approximate value of 42.720 if we round it to 3 decimal places. Similarly, we can find out S2, which will be the height of the triangular face at the front. So let's draw the height of the triangular face at the front. So let that be the height. So if we complete the triangle now, the right angle triangle, so that's the right angle triangle. Again, the standing height is 40 and the base of this triangle is half of 20, which is a 10. So if this is 20, that should be half of 20, which is 10. So S2 will be square root of 40 square plus 10 square. 40 square plus 10 square. 40 square plus 10 square. If we calculate that, we'll get 41.231 centimeters approximately. Sorry about that. So area of these two triangles, this one and that one, will be 2 times half of S1 times 20. So if we calculate that, we will get 854.4 centimeter square. Similarly, the area of the triangle at the front and at the back will be in total 2 times half of S2 times 30. Because for this triangle, 30 is the base and S2 is the height. So if we calculate that, we will get 1236.93 centimeters squared. These are all approximate values rounded to 2 and 3 decimal places. So finally, to calculate the total surface area, we have to add up this, the area of the circular base, and the area of the 4 triangles. So if we add 854.4 plus 1236.93 plus 600, we'll get the total surface area as 2691.33 centimeter square, rounded to 2 decimal places, rounded to 2 dB. Thanks for watching. If you like my video, press like, share, and subscribe. And don't forget to follow me on Facebook and TikTok. Thank you.